Okay, so the examples in the notes, what you want to do first is you want to, for every single picture, you want to start here with this. So I'm going to do these first three all in the same graph. You're going to do them on the separate graphs as they are in the notes. So we've plotted our points. We have A is the 0.23, B is the 0.05, C is the point -10. When you connect them, you get a triangle. You don't necessarily have to think about it as reflecting the whole triangle as just each point individually. So on the first one, it says to reflect on the x-axis. So the x-axis is this horizontal here, which means since all of the triangle is currently above, when we flip it, it's all going to go below. Now this point C, it's actually going to stay exactly where it is because it's on the reflection line. So we can go ahead and say that that's going to be our C prime. Now this point A, from the line of reflection, A is 3 above. So when we flip it, A would have to go 3 below. So that would be our A prime. B is 5 above, which means we would need to go 5 below. And so here's our B prime. So then when we connect those, we get the triangle that looks like that. And so the idea is that if we were to take our paper and fold it on the x-axis, the two pictures would match up. Now, I'm just going to leave this here for a minute, and now I'm going to do on the y-axis. So I'm going to do that in red. So the y-axis is the vertical one. Now notice that the original triangle, you have some of it to the left and some of it to the right, which means whatever's on the left is going to flip to the right, and whatever's on the right is going to flip to the left. But this B, just like the C, the B is on the axis that we're flipping, so that's still going to be our B prime. It's just going to stay right there. But A, notice that A is 2 units to the right, so when we flip it, it goes 2 units to the left. C is 1 unit to the left, so when you flip it, it would go 1 unit to the right. And then when you connect those, you're going to get a figure that looks like that. And so again, if you took your paper and you folded it on the y-axis, those two halves would match up. So now let me erase this, and we're going to do the next one. The next one says on y equals x. Now just above in the notes, there was a rule for when you're reflecting and what you can do to the points. So let me replot all of our points. We have B, A, and C. So here's the original triangle that we're starting with. If you go back up to the notes, what you see is that when it says reflect on y equals x, the point xy, it'll flip to yx. So here's what that means. If we want to reflect on y equals x, you may say, what is that line? Think y equals mx plus b. It has a slope of 1 and a y-intercept of 0. So this green dotted line right here, this would be y equals x. Meaning what we're trying to do is we're trying to take our triangle and we want to flip it over that line. And so imagine folding your paper on that green line. But what you can also do is you can think of it like this. Because of the rules at the top, if this point is 2, 3, then when we flip it, that would become 3, 2. So that would be right there. B is 0, 5, which means when we flip it, it becomes 5, 0. And C was -1, 0, so when we flip it, it becomes 0, -1. And so when you connect those, notice what you get. And so again, think about the whole folding of the paper. If you folded the paper on that green line, those halves are going to match up. Okay, as you continue on in the notes, the next types of examples, they're basically the same thing, but now, like on these first two, you've got new lines of reflection. So let me sketch these up again. All right, so we had A was, what was A? say 2, 3. B was 0, 5. And C was negative 1, 0. So our original triangle looks like that. Now on this one, it says we want to reflect on x equals 3. X equals 3 is it's a vertical line through 3 on the x-axis. So on the x-axis, here's 3. If we drew a vertical line through that, that's what we're going to flip over. So now, instead of flipping on the axis, we're going to fold the paper on this blue line. So we're going to take this triangle over to the left, and it's going to flip over to the right. So if you think about where A is, this point A, it's 1 unit away from the blue dotted line. So if it's 1 unit to the left, then the reflection would move 1 unit to the right. So here's A prime. B is 3 units to the left, which means from our line of reflection, this dotted line, we need to move 3 units to the right. C, if you count from the blue dotted line, 1, 2, 3, 4. C is 4 points to the left, so we need to move 4 to the right. So when we do that, it would put us right here. And then when we connect, there's our triangle. So again, folding that paper, you get the 2 parts that match up. With the next one, I'm going to leave this up here and just see if we can do this in one. The next one says to flip on or to reflect on y equals negative 1. So on the y-axis at negative 1, that would be a horizontal line. So now we're going to take this triangle and we're going to flip it over that y equals negative 1. So I'm just going to start with the point C. C is only 1 unit above, so we're going to go 1 unit below. Now B is from the red dotted line, it's 1, 2, 3, 4, 5, 6. So from the red, we're going to go 6 below. 1, 2, 3, 4, 5, 6. And then this point A, from the red dotted line, it's 1, 2, 3, 4 above. So we're going to go 4 below. 1, 2, 3, 4. And when we connect, we get that triangle. Oh, that's bad. That triangle. So if you took the black and you flipped it over, that would be the red one. And then for the last one, when it says to reflect on y equals negative x, again, we have rules for that at the top, and it's similar to the one. Okay, so on the last one, when you are reflecting on y equals negative x, what you're going to find is that y equals negative x is this line that's going diagonally down because the slope is negative 1. And so now that's what we're going to reflect on, so that's what we're going to fold on. If you scroll back up to the top, you'll see that when you reflect on negative x, y equals negative x, the point of xy, it will change to the point negative y, negative x. And so this point that was 2, 3, when you flip it and change the sign, it becomes negative 3, negative 2. This was the point 0, 5. So when you flip it and change the signs, it would be negative 5, 0. And then C was negative 1, 0. So when you flip it and change the signs, it would be 0, 1. And so when you connect, that was rough. That's how the reflection is going to look. So again, if you folded it on the green, that's how you get that reflection.